Hello, today I'm going to be talking about an issue where the electric eel wheel 6 has been turning off for some people as they're spinning. And it's really easy to turn back on with a foot switch or by turning the speed dial, but it has happened sporadically for a few people, and other people have seen it more often. And I've spent some time figuring out exactly what causes that, and I'll be talking about that today, plus some solutions for it. So first off, it stops and you can restart it again, but one other thing that actually happens to help identify this problem, to see if it's happening to you, is on the back there is a little green LED, and when you turn on the spinning wheel, it blinks 3 times just like that. The same thing happens when it resets, because what it's actually doing is there's some static electricity building up on this metal spindle here, and it resets the circuit board. It's not damaging anything, but it's pulling the circuit board pin low just for a little while, and that tells the microcontroller to reset, and you'll get it'll look exactly like it restarts. And because it always starts in a stopped position, that's why it's actually stopping. That actually has affected a lot of other spinning wheels. I've definitely seen some cases of this happening and heard it happening on other wheels when I did research into this, but I suspect that it's maybe a little bit worse for the electric eel wheel 6, kind of for 2 reasons. First, it spins really fast, and then the second is it's very well insulated because it is plastic. These support arms and the whole case is made out of glass reinforced nylon, which is a fairly good insulator. And then also on the bottom cover here, which you can just connect like that, there's these little rubber feet, and these are very, very good insulators. So that's why some people have been saying the problem goes away when they remove this bottom cover piece and just set this directly onto their table. That's going to help a lot more if you have a table that's a little bit of a conductor. Like obviously a metal table would work well. So a lot of things can sort of make your environment have this more likely to happen. And I don't really want to get into that, but anything that causes static electricity to be more likely is going to sort of increase your odds of seeing this, but also some wheels just don't seem to show it as often. The variability in this problem is a big part of the reason it took me so long to sort of figure out and really make sure that I understand the problem, so that I wasn't just hiding the problem for some cases, but like truly solving it. So I've got 2 different fixes here that completely solve the problem for me. And I suspect that either of these will fix the problem for most people, but both of them together should definitely fix the problem for anyone who's seeing it. So for the first solution, we will ground this spindle to the motor right here. The motor is connected to ground on the circuit board, and ground on the circuit board is connected to either ground on the battery or the negative terminal on your wall power. So connecting it to the motor is basically connecting it to a pretty good grounding system. So that's going to sort of remove all of the static from the spindle and solves it that way. So the first way I implemented this grounding fix was I just took a piece of tin foil, and this is much too wide. I cut this into a thin slice, and then I took some Scotch tape, and I just taped it from this back arm. I have it sort of inside of here so that it's touching the bearing when the flyer sits in there. And then I sort of run it down the outside, and I run it along here, and it's just sort of taped in place. And I run it on the inside, and I get to the motor like this. So that has completely solved any of the static buildup for me. When you set the flyer on here, it's grounded and behaves as you would expect. Now, there are more elaborate ways to do that that will make it look nicer. Some people online use copper tape, which I thought looked really nice. I guess you can just they use copper tape for several different purposes. It's pretty easy to get. And as long as it's a conductive, continuous line, it's going to work whether it's copper tape or tinfoil or even conductive markers and things like that should work, as long as it's going to stick to the nylon case. Another idea I came up with to sort of implement this same fix was to sort of try to hide the conductor a little bit, because I knew some people wouldn't like the look of that tinfoil solution. So for that, what I did was I have this is just standard black wire. I picked black because it's going to blend in with the case, and I'm going to sort of run it from up here where it's going to be able to touch the bearing all the way down to the motor, just like the other one. In order to do that, I had to drill 2 little holes in the case. One was right here, and I drilled one right back here. With those holes drilled, you'll just take your wire and sort of feed it through the electric eel wheel, like that. And I drew this hole in the back, actually went through 2 different parts, but it was a straight hole that I drilled. And then you just want to make sure it's more than long enough to get to the motor, and then you're going to cut it off. Then you'll want to strip the ends of the wire. So after sticking that wire in place, I used a little bit of super glue and a few pieces of tape just to hold it where I wanted. There's a little bit of exposed wire that's going to touch the bearing up here. The wire runs down this arm. I did find running it down the side where the tension dial worked a little bit better than the side with the spring. I just thought there were less things that got in the way. So I ran it down the side with the tension dial and then through here. And it really blends in. I don't know how it's going to show up on this video, but it really does blend in with the black case quite well. So it's running through here and then attaches to the motor. And I mean, in the bottom, you can see it easily enough in person, but again, that part already has other wires in it, so I think that really hides it quite well. Another option, if you wanted, is you could actually, there's a pin here on the programming header, and I'm going to talk about that in the next step. You could connect it to the pin all the way towards the center. It's got GND, which stands for ground, so that pin actually is a pin that goes directly to ground on the circuit board. But instead of putting a connector on there so I could connect it to this programming header, I just ran it directly to the motor like I did the tinfoil, and it's totally solved my problems just like the tinfoil did. So now I want to talk about the second fix that I mentioned I had found. So the first one was working on getting rid of the static buildup on the spindle so that shocks from that would not reset the microcontroller. The second one is actually doing a small but very easy modification to the microcontroller and how it works. So on the microcontroller, there is this programming header right here. And I'm actually going to show you an image because that's going to make it a lot more clear. You can see that there are 6 pins on this header, and the one farthest from the center I've labeled as 1, and then 2, 3, 4, 5, 6. You want to connect pins 1 and 4. I'll provide a link in the show notes to the item that will connect them, but you can get little short ones like this. I like the shorter ones just because they're a little bit neater, but I did test longer ones like this, which are easier to get on like Amazon and things. So either one of these solved the resetting issue for me as well. So all I do is I take like this. Let's see, let's get it right here in the video so you guys can see what's going on. So all I have to do is connect this pin number 1, skip 2 pins, and then pin number 4. And then I would probably, tape that extra wire, because this is a longer one, sort of down somewhere. And you just leave it like that. And what that's going to do is that's going to hold the reset pin high. So I'm connecting a high logic signal to the reset pin, and those are the 2 pins we just connected. And what that does is it prevents it from going low when there's a static shock sort of in the vicinity. That also fixed the stopping problem. It does, I mean, your spindle can still build up a charge now. So it sort of depends on which of these two you want. The most robust would be to implement both of these fixes, and it's up to you whether you want to do sort of this. This one is probably, it's completely invisible. The first one gets rid of all of the static, so I kind of like that one a little bit more from like a functional standpoint. But it's sort of up to you which of these two sort of fits your needs. If you're seeing the problem, if you're not seeing the problem, there's no need to do either of these. I will show you one other cool thing I did with a test jig over at a friend's house to really stress test this. And this is sort of how I proved to myself this was the problem, because I wanted to make sure I could understand what was causing the problem. I used a tool called an ESD gun to actually make the issue happen and then prove that my fixes solved it. So I've got a little video clip from that.
Hey guys, I'm in the basement of one of my friends who has an ESD gun that they're allowing me to test. And this is a real stress test using, this is sort of designed to simulate the static shocks that humans can give to devices. This is part of the testing that he does on his medical devices that he designs. So what we've got here is we can set it to all different voltages. I think it starts at 2 kV. I've got it set to 8 kV, so that's a pretty high voltage shock. And what I do is I just pull the trigger and I shock different parts of the system to make sure that it's not going to get reset. And the motor's definitely not stopping, which it would if any of these sort of reset it. So all of this testing looks like it's going really good, and that's because I have that jumper cable I talked about earlier connected.
And that's pretty much all I have. So I hope you all found this helpful, and thanks for watching.